So the topic is one-dimensional motion. That's the topic, the big topic for chapter 2. One-dimensional motion, motion along a single straight line, whether it's horizontal or, as we'll see later on in the chapter, vertical. But for now, our line is horizontal. Come back with me now to your house located at 2.1 miles, your friend's house located at the origin, and Publix located at 6.4 miles from the origin. Okay? And what I want to do is to use this picture here to imagine 3 different trips that we're going to take. You're going to take a trip. You're going to get in your car and take some trips. You're going to take 3 of them. Okay? And in each of those 3 cases, we're going to calculate distance and displacement as I defined them in the last lecture, last video, and we're going to use these definitions and see what these numbers come up with for each of these 3 trips. Okay. We're going to take the trips one after the other. So let's look at trip number 1 first. Trip number 1 is very simple. You get in your car and you drive to Publix. That's it. Super easy. Okay. So trip number 1. Trip 1. Distance. Actually, I'm going to move this over just a little bit. I want to use all the room I can on the right side of the board. So distance. Well, how far did you go, right? You went from, in trip 1, you're simply getting in your car and going from your house to Publix. How far did you travel? Right? How far did you travel when you did that? Well, you went from 2.1 miles to 6.4 miles. Right? So that distance, you traveled a total distance of 4.3 miles. Right? Because 6.4 minus 2.1 is 4.3. So the distance traveled is 4.3 miles. Right? That's correct. I did my math correctly in my head. Into the summer, I go a little slow, but I did it right. I subtracted 2.1 from 6.4 for a total of 4.3 miles. Okay? Now, in this case, displacement is the same. For trip 1, the displacement, right, distance that we just did was total length of travel from here to there. Displacement is really the same thing in this case. Delta x is x sub f minus x sub I. X sub f, when you see the subscript f, it means final. Final position. Remember, x is position. That's what we covered in the first video from this chapter. X is position, right? You got our 3 positions here. So this xf means your final position minus your initial position. Well, what's your final position? It's 6.4. Your initial position is 2.1. So it comes out in this case to be exactly the same. It is 4.3 miles. Okay. So trip 1, we got the same thing. A distance of 4.3 miles, a displacement of 4.3 miles. On trip 2, now, okay, so, is that clear? Again, if we were in a 3-dimensional classroom and you were in the room with me, I would say, are there questions? In this case, they both come out to be the same. Okay. Trip 2. They will not be the same this time. Distance equals what? Well, what's trip 2? You're going from your house Trip 2 takes you from your house to Publix and back to your house. Right? That's how I define trip 2. From you to Publix, back to you. Okay? So that distance is going to be 4.3 miles plus 4.3 miles. Equals 8.6 miles. So when you get in your car and you drive to Publix and you drive back, the distance you've traveled is 8.6 miles. Your odometer now reads 8.6 miles higher than it did when you started. See that? Okay, very intuitive. It's the total distance you traveled in your car is 8.6 miles. But the displacement, I don't need to write this out. I can just do delta x. Displacement, delta x, is your initial position for the trip minus, the displacement is the final position of your trip minus the initial position of your trip. It's right, xf minus xi. Right, that's the definition of delta x. But that equals where you started off, x was 2.1 miles. I mean, where you ended up, right? You end up at your house, right? You, Publix, you. You end up at your house. That's 2.1 miles. Minus your initial position, which was you, at your house, 2.1 miles. That means your displacement is 0. For trip number 2, your displacement is 0. Okay, you haven't, right? For displacement, all that matters for displacement is where you end up and where you started. Doesn't matter what you did between the two. If you started trip 2 at your house, you go to Publix and you come back to your house and you end your trip at your house, you have gone nowhere from a displacement point of view. You ended where you started. Your displacement is 0. In fact, you could have started at your house and gone and gotten on a Saturn V rocket and gone around the moon and come back to your house. When you get back to your house, no matter where you go in the cosmos, if you get back to your house, your total displacement for the whole trip is 0 because you ended where you started. That's how displacement is defined. Okay? That's how displacement is defined. So for trip 2, you end up going nowhere. You end up back where you started, displacement 0. But the distance traveled, the odometer reading on your car has increased by 8.6 miles. Okay? Now, I'm going to have to erase this right here and put our third trip. I'm out of board here. And I want to have all 3 trips up on the board at once. This is one of the restrictions of my little studio. That's not my studio. This studio down here is that I am limited in the amount of space I can cover. So trip 3, notice what I'm going to, before we erase, trip 3 is from your house to Publix to your friend's house. Okay? From your house to Publix to your friend's house. So on the way back, you go right past your house and keep on buzzing down the road 2.1 more miles to your friend's house. And now let's do the same thing as calculate distance and displacement for trip number 3, you to Publix to your friend's house. Give me a moment here to erase this. It shouldn't take long. Okay, that was good and easy. So let's do trip number 3, again calculating distance and displacement for it. All right, trip 3. And I'll write out what the trip is here because I erased it a moment ago. It's from you to Publix to your friend. From x equals 2.1 to x equals 6.4 to x equals 0 miles. Okay. Distance. Very easy. Distance, well, it's 4.3 miles from you to Publix. And then 6.4 miles from Publix to your friend's house. So if you do this trip, okay, you'll have added 10.7 miles to your odometer. That is the total distance traveled. That is the total length of travel, 10.7 miles. Taking this third trip from your house out to Publix and back to your friend's house. You have traveled 10.7 miles. Right? 4.3 from you to Publix and 6.4 from Publix to your friend's house. But the displacement is highly amusing. Okay. Delta X, again, is the your final position minus your initial position. And again, all that matters with displacement, all that matters with displacement, all that matters with the displacement is your final position and your initial position. Doesn't matter what you did in between those two positions. What we get here is your final position is your friend's house at the origin, which is, say it out loud. I heard you. You said 0. Minus your initial position, which is 2.1 miles. So your displacement for trip number 3 from your house to Publix to your friend's house is negative 2.1 miles. Because it's negative for the very simple reason, listen well, it's negative for the very simple reason that you ended up to the left of where you started on the number line. You ended up at a more at a lower value position than you started with. If you had come from Publix to your house, if we had a trip number 4 that just went from Publix to your house, that would also be a negative displacement because you traveled in the negative direction down the number line. Right? We defined right to be positive. We picked right to be positive because why not? So if we move to the left on the number line, you have a negative displacement. If you move to the right on the number line, you have a positive displacement. Now, one last important thing to say about distance and displacement. As I've indicated, distance is what your odometer reads. Your odometer never goes negative. Even when your tires spin, like in Ferris Bueller's Day Off, right? Spinning the tires backward doesn't matter, right? It didn't make a difference. Distance is always positive. Distance is a scalar quantity. Okay. If you get in your car and you go anywhere, your odometer goes up. The total length of travel, the distance traveled, is always positive. That is, distance is a scalar and it's always positive. Okay. Displacement, however, can be positive or negative. We see a positive displacement here with trip 1. We see a 0 displacement here for trip 2, even though you went to the store and back, your displacement was 0 because you ended up where you started. But you can also have a negative displacement. If you end up sort of to the left on this number line, you have a negative displacement. If your final position has a lower value than your initial position, then you have a negative displacement. So it can be positive or negative, and displacement, therefore, or displacement is a vector. Okay. All right. I think I've covered it. Next up, speed, and velocity. Oh, and I'm going to say one quick word about position as well at the beginning of next video. So, a very important comment about position to lead off the next video, coming right up. Don't miss it. See ya.